going to discuss about Thevenin's theorem. Thevenin's theorem. So in Thevenin's theorem, what does Thevenin's theorem state? Say that when we have a linear circuit, we always have a load, and this load is to vary. This load is to vary because it's not all the components will be running in the same time. So if we have two terminal linear circuit, we already discussed about linear circuit in the previous video. So now this terminal linear circuit is just different component inside. It's just different component inside. So Thevenin's theorem says that when we can replace this linear circuit by a fixed circuit, which will have the voltage VTH and a resistor RTH. This resistor RTH is representing all resistors that are in the linear circuit, and the VTH is the voltage which represents the voltage in the two-terminal linear circuit. So we are going to convert this two-terminal linear circuit to a VTH. We call Thevenin's voltage, and RTH, Thevenin's resistor. Now, so our circuit is going to be like, let's say for example I have this one. If I have like this example, let's say I have this one. In this one I have this two-terminal linear circuit. I have the load. This two linear terminal circuit is supplying the current to the load. We know what is load. We know linear circuit. Now we're going to convert it. We are going to convert this to linear circuit to a circuit which has RTH and VTH only. It will have VTH and RTH. Now we are going to see how to determine this RTH and how to determine VTH. To determine both, it will depend when our circuit which has a dependent source or does not have dependent source. Does not have. Now, first of all, in this video we are going to see if there is no dependent source. There is no dependent source. If there is no dependent source, how to determine the value of RTH, how to determine the value of VTH when no dependent source. In this video, no dependent source. Now, if there is no dependent source, how to determine RTH and how to determine VTH? First, to determine the VTH, to determine VTH, we will, or RTH, we will off all independent source. We will off it, so that when we off it, we will determine independent source. I want to determine the value of RTH, and we know that when we are going to off independent source, if it is voltage is going to be shorted. When it is current, we see in the previous video, current source is going to be open. So let's see some example. Now let's say for example we have this one. In this example we are going to see some example to determine the VTH and RTH. We say VTH we call Thevenin voltage and RTH Thevenin's resistor. So I will have in this one I have this circuit. In this circuit I want to determine the Thevenin circuit. We can say Thevenin circuit or VT hash. If you say Thevenin circuit, means that I will have to determine VT hash and RT hash. Now, first of all, I have to determine the value of RT hash. What's the rule? There is no dependent source. There is no dependent source. So if there is no dependent source, I have to off all independent source. And I know the rule to off all independent source currents. We discuss. So my circuit is going to be, since it is current voltage, is going to be shorted, and I will have this one. I will have this one. I will have this one. Now, since it is a current source, it's going to be open. I will have this one. Now, from the load, this one is the load. RL. RL is the load. Now representing our load. For the load, we will open the load. We'll open the load, and that I will have A here and a B. Because why? Because this all from here is my linear circuit, and my linear circuit I'm going to replace by RT hash. So now I will have this in this part, the RT hash. I have to determine the RT hash. How to determine RT hash? RT hash, to determine RT hash, I have to determine the equivalent resistor. So I have 4 here, I have 12 here, I have 1 here. We see in the previous video how to determine equivalent resistor. We will check this one and this one are parallel. How? Because same node, we discuss. So since they are parallel, I will have 4 multiplied by 12 divided by 4 plus 12. We know how to determine equivalent resistor in parallel. So determine this one is going to be one resistor, this one parallel. This equivalent resistor is going to be in series with this one. So since it should be in series, I will add plus 1 to determine the value of RT hash. Because the value of RT hash is the equivalent resistor of this linear circuit. So I will have 4 multiplied by 12 divided by 4 plus 12 plus 1 equal 4 equal RT hash equal 4 ohms. Now I have already determined RT hash. Now, how to determine VT hash? To determine VT hash, to determine the value of VT hash, I will come back to put all my independent source. I have to put all my independent source. I have to put all my independent source. So I will have my independent source here, which is plus minus 32. Here I will have my current source, which is 2 ampere. Now, but I will always open the load. Now, this one is going to be my VT hash, the voltage of this linear circuit. Now, to determine VT hash, let me see. Since this one is open, there is no current will flow here. Why? Because this one is open, nothing is here. So this VT hash is the same as this one. Since here it is the ground, this voltage is going to be my VT hash. Same thing, same node. Here is going to be my VT hash. Same. Now, because here it is the ground, 0, 0. Now, how to determine this voltage? To determine voltage, if I determine the voltage of this 12 ampere, this was going to be 12 ohm, is going to be my VT hash. Because it should supposed to be VT hash minus 0. The voltage of this ohms, 12 ohms. So how? I have different methods. I can use mesh analysis. I can use mesh analysis here. We discuss or discuss mesh analysis in the previous video. So I can also use KCL. What does KCL say? Current flowing here equal this current entering equal this current leaving. No current will flow here. So I will have 32. I will have 32 minus VT hash minus VT hash, because I have 32 minus VT hash, this node, divided by 4, because this 4, plus this current 2 ampere is entering this node, plus 2 equal this current will leave VT hash divided by 12. We discussed in KCL and nodal analysis. We don't need to put VT hash minus 0, since 0 is 0. Now, no need to put this current because it's leaving. Because this no current will flow here since it is open. Now, I have this one, I have to find VT hash. If I multiply all of them by 12, I will have I'll have 12 going, is going to be VT hash here. VT hash equal, you multiply by 12 here is going to be 24, plus you multiply by 12 here is going to be 3, multiply by 32 minus VT hash. Now you will use here and determine the value of VT hash in this equation. Now if I determine the value of VT hash, I can draw my Thevenin circuit. To draw my Thevenin circuit, say I will have this one is going to be plus minus VT hash. I will have my RT hash, because, and I will have my load. I'm going to be my RL load. Now this one was my linear circuit. I replace it with the VT hash. I have the value. I already calculate RT hash, which is equal 4. VT hash will calculate from that equation. You have the value of RL load, let's say 6 ohm. Now I want to determine this current IL, current flowing at load, current flowing in the load. To determine the current flowing at the load, we already know from the previous video, when two resistors are in series, want to determine the current, I can determine the some current will flow. So it will be the VT hash from Ohm's law, VT hash divided by what? This RT hash plus RL. Because I need this current is the same flow in here. So just to take the VT hash, the voltage of the source, divided by the equivalent resistor. The equivalent resistor, since it is in series, is going to be the sum of them. So now I determine the current flowing in the load, I determine the VT hash, I determine the RT hash. Now I already determine my Thevenin circuit. Now let's say to see another example. In this example, we are going to have to determine the Thevenin circuit. Now, if we see this circuit, this one is the load. This one I is the current I. So I want to determine the Thevenin circuit and determine, if you say Thevenin circuit, means that VT hash and RT hash. You have to keep in mind and the RT hash. Now this one, the load. I have to find the RT hash. How to find the RT hash? Of all independent source. I have this one, this voltage is going to be off by shorted. I will have the 6 ampere. Current source is going to be off by opening. I have 6, I have 4. This one is open, this one is shorted, and I have A and B. So I'll determine RT hash. Always the load will have to be open. Always the load have to be open. We have to keep in mind, in this case, when there is no dependent source. In this case, there is no dependent source. When there is dependent source, we'll discuss in the next video. Now I have to find the RT hash. Let's see. Oh, I have this 6, I have this 4. These 6 and 4 are what? In series. So I'll have 6 plus 4 is going to be equal to 10. This 10 means that my circuit is going to be like this one. I have this 4 here, and I have the 10. The 10 is the equivalent of this one. These 10 and 4 are what? Are in parallel. So I determine RT hash equal 10 multiplied by 4 divided by 10 plus 4. Now I already determined the RT hash. I have to find VT hash. To find VT hash, I will bring back our voltage source and the current source. So my circuit is going to be like this one. I will bring back my current source. I will bring back we have to keep in mind our voltage, our load is have to be removed. So I will have my voltage source, which is plus 10, 12, yeah, and I have my current source, which is 2 ampere. I have my load that I already removed. Now I have to find the VT hash. VT hash means that VT hash. I have this 6. VT hash means that VA. How to determine? To determine this one, I have different method analysis that we learned before. Either I use mesh analysis, but we have to remember, because in this case we have a current source. Since we have a current source, we'll remove it. We'll remove because it will be a super mesh. You have to remember. So means my circuit is going to be like this one. Means that my circuit is going to be, since I'm going to remove this one, my circuit is going to be this one. That's minus 12, 6 ampere, 6 and 6 ampere. Before it was supposed to be 6 plus 6. 6 plus 6, it was supposed to be 10. 6 plus 6 plus 6 is going to be 12. 12 multiplied by, so this 12 in parallel is going to be 12 multiplied by 4. And I put 10, I think. Mistakenly put 10 here. Instead of 12, I put 10. So now I will have 6 plus 6. I will have this 4 again. I will have this one. This source you already remove. This one already removed. No need to put. I have VTH here. The VTH here. Now it was this one. I have this one. I have this one. Now I have this I1. I have I2. I have I2. At the time you have to remember the mesh analysis is going to be minus 12. 6 I2. You have to see the previous video for mesh analysis for better understanding in this case. Plus 6 I2. Here I1. 6. Now we are going to 6 I2 plus 4 I2 equal 0. Now we found the first equation. Second equation, I have to check which one is going the same direction. Same direction with this one. It's I2. So I2 is going to same direction as we discussed before. I2 is going to be minus I1 equal what? 2. I will start I2 because I2 is going to the same direction with the current source. So I have these two equations. I will determine I1 and determine I2. Now, if I determine I want I2, for me I need what? I need VTH. So this voltage is going to be equal. The voltage, this one, is going to be 4. VTH is going to be equal 4. This resistor multiplied by the current. Which current? The current is going to be this current I2 multiplied by I2. The I2 already calculated from here. So I will get VTH. Now if I found VTH, I found RTH. Means that my circuit is going to be my Thevenin VTH. I have RTH. I have my load. Now our load RTH here. Now if I found RTH, I can find the current I by what? Equal VTH as we see before, divided by RL plus RTH, equivalent resistor. That is for when there is no dependent source. Thank you for watching this video. Next we will discuss when there is dependent source.